This is group 14 for the relations project. Our domain is 1, 2, and 3 times 0, 1, and 2, and the relation is A1 and A2 are related to B1 and B2 if A1 equals B1. These are the ordered pairs for the relation, and we know this because in each of these pairs, they all have the same A1 and B1 values. So for 1, 0 related to 1, 1, 1 equals 1, which is A1 and B1. And same goes for all of these. In the matrix, a 1 is shown where a pair is in the relation, and a 0 is shown where a pair isn't. So, for example, 2, 0 and 2, 1 have a 1 because they are in the relation with 2 and 2 being A1 and B1. But the pair 2, 0 and 3, 1 are not in the relation because 2 does not equal 3. And this is the arrow diagram for the relation. 1, 0 is related to itself, as well as 1, 1 and 1, 2. 1, 1 is related to itself, as well as 1, 0 and 1, 2. And 1, 2 is related to itself, as well as 1, 1 and 1, 0, because they all have the same A1 and B1 value being 1. And same goes for these being 2 and these being 3.
Is this relation reflexive? Well, in order for a relation to be reflexive, every element of the set has to be related to itself. So if we look at a few examples, we have the element 1, 0 is related to 1, 0. Well, in order to satisfy the relation, we have to see that A1 is related to B1, which they are. We have 1 and 1. So we know that 1, 0 is related to 1, 0, and 1, 0 is the same as 1, 0, which means that 1, 0 is related to itself. And we see the same thing for 2, 0 and 3, 0. We can even see this in our arrow diagram, which is represented by these arrows pointing from each element to itself. And we see that every element in this relation has an arrow pointing to itself, which means that every element in this relation is related to itself, meaning that this relation is indeed reflexive. Well, is this relation anti-reflexive? No, because in order for a relation to be anti-reflexive, none of the elements in the set can be related to themselves. And we just showed that all of the elements in this set are related to themselves. But if we want to look at one example specifically, well, we see that 1, 0 is related to itself because 1, 0 is related to 1, 0 because A1 is 1 and B1 is 1, meaning that they're related to each other, and 1, 0 is the same as 1, 0. So this relation is not anti-reflexive. Is this relation symmetric? In order for a relation to be symmetric, the ordered pairs can have their order flipped and have X be related to Y and Y related to X. So if we look at an example, we have 2, 1 is related to 2, 0. So we can call 2, 1 X and 2, 0 Y. And if we change the order, flip the order of these elements, we have Y is related to X. Well, we know that 2, 1 is related to 2, 0 because the A1 is 2 and the B1 is 2, which means that they're related. And when we flip the order, we still have that the A1 is 2 and the B1 is 2, meaning that they're related. And if we take a look at our arrow diagram, we see that 2, 0 is related to 2, 1, and 2, 1 is related to 2, 0. The arrows that have points at both ends are showing that the elements are related to each other. And we can see that all of the elements in this relation have the arrows pointing both ways, which means that all of these elements are related to each other when the order of the elements is flipped. So, is this relation antisymmetric? Well, no, because in order for the relation to be antisymmetric, no pairs of elements that are related can be flipped and still be related. So, since we have that 2, 0 is related to 2, 2, and 2, 2 is related to 2, 0, it proves that the relation cannot be antisymmetric. Because once again, we have the A1 as 2, the B1 as 2, and then when we flip the order of those elements, we have that the A1 is 2 and the B1 is 2 as well.
The relation is transitive because when x is related to y and y is related to z, x will also be related to z. For x to be related to y, the x's of the ordered pairs must be equal to each other. In this case, 1, 0 is x and 1, 2 is y. So they're related to each other, and so for y to be related to z, the x's must be equal, meaning that x from the first relation would also be related to z. So y is 1, 2, z is 1, 1, and they're related. Then x is 1, 0, and z is 1, 1, and they're also related, proving it's transitive. The relation is an equivalence relation because it is reflexive, symmetric, and transitive. The first three rows in the matrix, 1, 0, 1, 1, and 1, 2, are a set, and the second set is 2, 0, 2, 1, 2, 2. The third, 3, 0, 3, 1, 3, 2. These three sets form a partition of the relation. Every ordered pair is either equivalent to 1, 0, 2, 0, or 3, 0, with nothing overlapping as shown in the matrix.